Welcome to Internet Quality Academy. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. In today also, we are going to discuss about a very important topics about the concrete. That is, what is carbonation of concrete and how this happen and what is the detrimental effect of carbonation of concrete and how we can reduce the impact on the carbonation on the concrete. So today's video, we'll discuss each and everything about the carbonation and concrete. So stay tuned until the end to get the full information about the carbonation of the concrete. So what is carbonation of concrete? The carbonation of concrete is that the CO2 or the carbon dioxide present in the atmosphere, it start reacting with the concrete. So what this reaction is called the carbonation of the concrete. So first we need to know what is carbonation of the concrete. See, carbonation of concrete is the process where carbon dioxide from the atmosphere reacts with the calcium hydroxide. Now, in the concrete, the calcium hydroxide is present. Now, whenever the carbon dioxide start reacting with this calcium hydroxide, that's present in the form, and it will produce calcium carbonate, that is CaCO3, and this occurs in the presence of moisture and typically start at the surface and gradually moves inward. So this reaction is called the carbonation of the concrete. Now, what is the chemical reaction for the carbonation of the concrete? That already we saw that calcium carbon dioxide with calcium hydroxide in presence in the concrete react and produce calcium carbonate and water. This carbon dioxide from the atmosphere penetrate to the concrete pores and reacts with calcium hydroxide and calcium carbonate and water. So these are the chemical reactions. So in simple word, that carbon dioxide from the atmosphere react with the concrete, or that is calcium hydroxide, and produce calcium carbonate and water. This process is called the carbonation of the concrete. Now, what will happen? What is why we are thinking about this? Maybe if this process can happen, but it has a detrimental effect on the concrete. That is why the carbonation is very much harmful. So, what will happen if the carbonation of concrete is happening? First is the pH reduction. Now, carbonation lowered the alkalinity of concrete from 12 to 13 to below 9. Now, concrete has the alkalinity of the between 12 to 13. Now, if the carbon dioxide reacts with the calcium hydroxide and produce calcium carbonate, this alkalinity reduces to 10 to 9. So what is happening if this pH is reduction in below 9? Then the steel reinforcement corrosion will start. Why? Concrete's high pH protects the embedded steel bars by forming a passive oxide layer on the surface of the steel. Now, this high alkalinity of the concrete is help us to reduces the corrosion of the reinforcement. Why? It is making a protective layer or the oxide layer over the concrete. Now, whenever this pH is lowering down due to the carbonation, this oxide layer or the protective is breaking down. Now it is open to the moisture, to the chloride, to the carbon, then the corrosion started. So that is why the carbonation of concrete is very much harmful for the concrete, and corrosion of the steel due to the carbon dioxide called the carbon induced corrosion. In the bridge, whenever in the urban areas, there is a lot of car every time, and the carbon emission from the car can cause the carbonation induced reinforcement corrosion into the bridges and etc. Then what will happen if there is a steel reinforcement start corrosion? As steel corrodes, it expands, causing cracks in the concrete. Over time, this leads to surface falling, further reduction in the structural integrity. Now, if the corrosion started, all we know that the volume will increase, and this increase in volume produces the stress or increase the stress. And if it is increased, the cracks falling, it will happen. Now, what will happen? Then carbonation shrinkage. Now, What is shrinkage? And that is a reduction in volume or due to the chemical changes or thermal changes, whatever. That is called the shrinkage of the concrete. So what is shrinkage? What the different types of shrinkage? I have made a detailed video. Link is there or in the description. Please check. You will get the full information about the shrinkage of the concrete. Now, what is happening? When this carbonation of shrinkage occurs and the carbon dioxide from the atmosphere reacts and they produce the calcium hydroxide. This chemical reaction causes the concrete to shrink and can lead the cracks over the time. So this reaction also reduces the concrete volume, and again the stress is generating, and for the stress again this is crack is generating, that called the carbonation shrinkage. And due to this carbonation shrinkage, again this crack is the weak point to penetrate all the chemical substances and the moisture, which is eventually corrode the steel, and concrete will minimize or concrete reduces the lifespan or the durability. So that is why the carbonation of shrinkage or the carbon dioxide is very much harmful. Now, not only this pH reduction, steel corrosion, reinforcement corrosion, cracking, or the carbonation or shrinkage is happening due to the carbonation. Another thing is also happening, that is a biological growth on concrete due to carbonation. Now, we can see some old concrete or some this algae is forming, or the some other vegetations or the biological growth is there. Why? Because of this carbonation of the concrete. Why? The carbonation lowers the pH of concrete, reducing the alkalinity. Freshly placed concrete has a naturally high pH, that is 12 to 13, which is impossible to inhospitable to most forms of biological life. In this high alkalinity, the biological life cannot sustain. That is why in the concrete, we cannot see the forming of the biological life. But when the carbonation of concrete is happening, it is reducing the alkalinity or reducing the pH. It has become 9 to 10. So now this biological form can happen in this pH range. Now, and this lower pH, the surface of the concrete becomes more suitable for biological organism to colonize, especially in damp environment. Now, if the pH is lower down and there is a moisture, then the biological form can happen. So what will happen if the biological form is happening due to the carbonation? First is aesthetic degradation. Biological growth can cause unsightly discoloration, stains, and surface blemishes, affecting the appearance of the concrete structure. That will happen. And then surface erosion. In some cases, the physical attachment of organisms like lichens, moss, and can lead the slight surface degradation, especially if growth becomes extensive. The roots of the filaments of these organisms may penetrate small cracks or voids, leading to more erosion over time. Now, this will happen. The first is aesthetic degradation, then the surface erosion, and of course the crack. And this crack will be a weak zone to penetrate more chemicals, carbon dioxide, moisture, etc. Now, whenever the biological form or the plant is growth, they will cap the more moisture. So biological growth increase moisture retention, potentially leading the freeze cycle in cold climate, where retained water freeze and expand, causing surface scaling and cracking. So if there is a moisture biological form, they will retain the moisture, and this moisture will penetrate inside the concrete, or it can lead the freeze cycle. In the both way, our concrete lifespan will deteriorate, and concrete due to durability will be problem. And again, promotion of the further carbonation. This moisture retained by biological growth can accelerate carbonation deeper into the concrete, further lowering the pH and increase the vulnerability of embedded steel reinforcement to corrosion. So this biological growth is also happening due to the carbonation of the concrete, and this will also affect our durability or the properties of the concrete, which is not acceptable at all. So that is why the carbon dioxide or the carbonation of concrete is very much harmful for our concrete. Now we need to know what are the factors affecting the carbonation. That all we have discussed. That's the concrete permeability, water cement ratio, moisture ability, cement composition, environmental exposure, and the concrete thickness and the concrete cover. So what are the durability factors affecting? That all are affecting the carbonation. And whatever the where the concrete is exposed, that is the carbon dioxide level of that atmosphere, that is also affecting the carbonation of the concrete. The next is how to avoid carbonation. That we already know what is carbonation, what is the chemical reaction, why it is harmful, and how it is affecting the carbonation. Then how to avoid. First is low water cement ratio. That all this is a durability issue. So what are the factors that are affecting the durability? I have made a detailed video. Please check there, or link is there. You will find out what is the factor affecting the durability. That all are factor will affecting the carbonation, and that all we need to protect in order to avoid the carbonation of the concrete. That is a low water cement ratio, proper curing, use of pozzoning additives, use of coating and sealant. If we are using coating or sealant, what will happen? The carbon dioxide will not penetrate inside the concrete. That apply protective coating, sealants or waterproofing layers on exposed surface to reduce the ingress of CO2. Then sufficient concrete cover, that is the main things of the durability, that if the sufficient cover is there, that the carbon dioxide will not reach to the steel and there will no corrosion will happen. Then the environmental control, that is very much important. This is the factor. If the carbon dioxide in the atmosphere in the desired level or in the acceptable limit, then the carbonation will not happen. But due to the carbon emission or the carbon footprint on the earth, the carbon dioxide level is increasing, and as a result our concrete is also exposed to the carbon atmosphere, and the carbonation of concrete is happening. So another way to control the carbonation of concrete, to reduce the carbon footprint on the planet. So these are the all about the carbonation of the concrete. That is what is carbonation of concrete, what is the chemical reaction, why it is harmful, and what are the factors that are affecting carbonation, and how to avoid the carbonation. And I hope you find it useful. And if you find it useful, kindly subscribe my channel and hit the bell icon, so that whenever I upload a new video, you will get immediate notification. And I'm waiting for your valuable comments, so that from your valuable comment, everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching me.